Here is a matching type question on general organic chemistry. Study the items in both columns carefully. Try to work out the matching before we solve it together. Let us first understand the key concept here. These equilibria are governed by the relative stability of carbocations, carbanions, and aromaticity and aromaticity. A. Forward direction analysis. Reactant side, cyclotetraene, COT, is a tub-shaped, non-planar, non-aromatic 8-pi-electron system. It acts as a hydride donor, losing H to pH3C plus trityl cation generated from pH3CBr as an electrophilic hydride abstractor. Product side, the cyclotetraenyl cation, C8H8 plus, formed would be a 6-pi-electron system in a planar ring. This is aromatic. Huckel rule, 4n plus 2, n is equal to 1. Gaining aromatic stabilization of 6-pi electrons drives the reaction forward strongly. pH3CH, triphenylmethane, is a stable neutral product. Therefore, the products are more stable than the reactants, and the equilibrium lies to the right, forward. B. Backward direction analysis. Reactant side, the cyclopentadienyl anion, C5H5-, is a 6-pi-electron aromatic anion extremely stable, pKa of cyclopentadiene 16. CH4 is a very weak acid, pKa 50. Product side, the cyclopentadiene, neutral, sp3 carbon with methyl, loses its aromaticity since the ring is now non-aromatic with the added methyl group disturbing the system. CH3-, methyl carbanion KCH3, is an extremely strong base, far less stable than the aromatic cyclopentadienyl anion. The acidity comparison, cyclopentadiene, pK 16 versus methane, pK 50. The equilibrium always favors the weaker acid and weaker base on the product side. Here, reactants contain CH4, weaker acid, and C5H5-, K+, weaker base relative to CH3-, so the equilibrium lies to the left, backward. The aromatic cyclopentadienyl anion is far more stable than CH3-, so the reaction does not proceed forward. Why other directions fail? A. Backward would require breaking aromaticity of the product cation, energetically unfavorable. B. Forward would require the much stronger base CH3-, to form at the expense of the aromatic stabilization of C5H5-, energetically unfavorable. Therefore, the correct answer is A. Forward, B. Backward. Therefore, the correct matching is A matches forward, B matches backward.